Hello everyone, and welcome back to another video on this channel. With hurricane season being well underway and lasts through November 30th, I want to take the time and go over some of the basics regarding hurricanes and tropical cyclones. These include terminology, structure, and tools used to forecast hurricanes. So without further ado, let's dive into the video, and I'll start with the terminology used while forecasting hurricanes. So the National Weather Service in Mobile has done a really good job of compiling some definitions here, some tropical definitions, and also climatology of hurricane season, and also some of the products that are issued for tropical storms and hurricanes. So I'll put a link in the description box down below to this list here, and I'm just going to hit the high points. Here are some of these definitions. So first up, I'm going to go through the life cycle of a tropical cyclone, and I'll start with and so these usually begin as what we call a tropical wave. And a tropical wave is basically just referring to an upper level trough that is out in the tropics. On the surface, this creates an elongated area of low pressure and is often the precursor of a development of a tropical cyclone. Tropical cyclone is kind of an umbrella term that is used to describe in the Atlantic Ocean a tropical depression, tropical storm, and a hurricane. So there's a few specific criteria that's used to designate a tropical cyclone. First being what we call a warm core system, which means the temperature is warmer inside the storm compared to the surrounding environment. So you want warmer temperatures inside the center of the storm compared to surrounding the storm. Second, we are looking for a well-defined center and closed circulation, usually found in the surface winds. And third, we need organized thunderstorms or convection surrounding that area of circulation. So tropical cyclones are classified based on maximum sustained winds. A depression has wind speeds less than 39 miles per hour, and a tropical storm has winds between 39 and 74 miles per hour, and hurricanes have maximum sustained winds greater than 74 miles per hour. So here is the Saffir-Simpson scale, which is a scale that categorizes hurricanes on a scale of 1 to 5 based on wind speed. And so this is from the National Hurricane Center, and they specify that the scale does not take into account other hazards such as storm surge, rainfall, the size of the storm, whatever. The Saffir-Simpson scale only takes into account the maximum sustained winds, and so categorizes hurricanes on a scale of 1 to 5. A category 3 or higher is considered to be a major hurricane. The tropical cyclone life cycle ends with what we call a post-tropical cyclone. So there are two types of post-tropical cyclones. We have the extratropical cyclone and the remnant low. So extratropical cyclone is when the system of any intensity gains an additional source of development, mainly resulting from the temperature contrast between cold and warm and cold air masses. So, and say like a frontal zone for the most part. And tropical cyclones are not associated with fronts, is one thing that we consider when designating a tropical cyclone. So Hurricane Sandy from 2012 is a perfect example of this. So I can pull up the Weather Prediction Center's surface analysis to help show this. From Hurricane Sandy. So this is towards the end of October, and we have a frontal zone that is draped from eastern Canada down through the eastern seaboard of the United States, and then here is Hurricane Sandy that's coming up the east coast of the United States. So we go 24 hours later, and you can see how Hurricane Sandy then interacts with this frontal zone here as it makes that westward shift towards the Jersey Shore, and then it becomes associated with frontal zones, and so then it is then designated an extratropical cyclone because it lost its tropical characteristics. And so that's just an example of how that extratropical transition can work. And so the other kind of post-tropical cyclone is a remnant low, when the storm becomes so disorganized that there's no well-defined center or organization, and the maximum sustained winds are less than 39 miles per hour. So it's basically that just means that the storm has died out and you just have a remnant low pressure. That's all that you have left. So that's going to do for the basic terminology. Now I'm going to move on to the environmental conditions and structure for tropical cyclones. So there are at least 4 main different factors that create a favorable environment for tropical cyclones to develop. First, we need warm ocean waters of at least 27 degrees Celsius or 80 degrees Fahrenheit. And not only we need warm ocean temperatures, we need deep warm waters, usually down to at least 50 meters. Second, we need an unstable atmosphere for thunderstorms to develop. And we also need moist and saturated mid to upper levels of the atmosphere to sustain those thunderstorms. Finally, strengthening tropical cyclones need weak vertical wind shear, typically of about 20 knots or less. And so the reason why that is because you can think of tropical cyclones as kind of, they need a warm bubble here. And so tropical cyclones are vertically stacked weather systems. So that means the mid to upper level circulation is aligned with the surface circulation. And so strong vertical wind shear tends to skew that mid to upper level circulation away from the surface circulation. So you kind of have, it kind of disrupts that bubble that tropical cyclones need. So that's why you need an environment with weak wind shear. So now moving on to the structure of a hurricane. Here, there are 3 main features that I want to discuss: the eye wall, and the outer rain band. So weather.gov/jetstream has a pretty good schematic of the structure of a hurricane, and so we're going to start here with the eye, and it's a very important feature of a hurricane. So the eye is located towards the middle of the hurricane and the center of the surface circulation, and results from sinking air in the center of the storm. And so this clears out all the clouds and precipitation out of the eye, and so it makes that the calmest part of the storm. The character of the eye tells a great deal of how well organized the hurricane is, such as minimum pressure and the temperature inside the eye, which is also the warmest part of the hurricane. I'll talk more about the eye and its importance for hurricane forecasting towards the end of the video. So next up is going to be the eye wall of the hurricane, which is the strongest part of the hurricane, where a ring of intense rain and wind wraps around the eye. And the most hazardous part of the eye wall is kind of that right front quadrant, where you have the strongest winds and the strongest storm surge. Some of the more intense hurricanes may develop more than one eye wall at a time. This is the beginning of an eye wall replacement cycle, when the outer eye wall develops and cuts off the inner eye wall from the warmer ocean temperatures. This temporarily weakens the hurricane as that inner eye wall dissipates and the outer eye wall then becomes dominant. The replacement cycle is complete when the new eye wall contracts, and this can cause rapid intensification of that hurricane. Then we will have the outer rain bands, and as the name suggests, these can occur on the outer edges of the hurricane. These occur in a counterclockwise fashion along with the motion of the hurricanes. Outer rain bands can potentially cause gusty winds over 40 miles per hour, very heavy rain, and occasional tornadoes. So that's going to cover it for the structure of tropical cyclones and hurricanes. And so next we're going to move on to some of the tools that are used to forecast hurricanes. 2 of them I'll focus on are satellites and recon missions by hurricane hunters. So starting with satellites, there are 3 main channels or bands that are useful to track hurricanes: visible, water vapor, and infrared imagery. Without getting too deep into the weeds here, I'll go over why each of these are used to track hurricanes for the purposes of this video. So the first up here is going to be visible imagery, and we typically use channel 2 or the red band for that. And this has a wide variety of uses for very various weather phenomena, but specifically for hurricanes, it gives meteorologists clarity of the location in the center of where the storm is at. This gives us confidence on forecasting the track of the hurricane, as we can see in real time where the storm is located. And so next up here is going to be infrared imagery, and I'll scroll down to the bottom here. And so this is the traditional infrared band, and this is also used for a pretty wide variety of phenomena, but specifically for hurricanes, the hurricane intensity and analysis of that hurricane. So essentially, we use this imagery to estimate the temperature of our cloud tops. The darker colors indicate colder cloud tops, which tells meteorologists where the deeper convection is located. The deeper or taller the storms are, the stronger the hurricane likely is. So where you have colder cloud tops, that's where your stronger thunderstorms are located. For example, here is Hurricane Ernesto that's tracking through the northern Atlantic at this time of this recording. And so where you have the darker reds here, this is where our colder cloud tops are located, as you can see here on the legend on your right. And so this is where your stronger thunderstorms are at. So that's visible and infrared imagery. So for water vapor, while tracking hurricanes, I prefer to use RGB imagery, as we can interpret the different kinds of air masses that will interact with the hurricane. So how this data is retrieved is beyond the scope of this video. Maybe it's a video for another day, but I'll just go over how to interpret this imagery for now. This can tell us where we have dry, dusty air that comes off the coast of Africa. You see here on the right. That's kind of covered up by my pen, but that's okay. And so this can also tell us where we have moist and saturated air. So the drier air is in the oranges and reds that comes off the coast of Africa. And where we have the greens here, over here, this is where we have moist and saturated mid to upper levels. And so that's what is needed for hurricanes, as discussed previously in this video. Hurricane Ernesto kind of originated in the May development region around this area, and then tracked to the northwest over next to Puerto Rico, and then kind of curved up here to Bermuda and tracking up now through the northern Atlantic. So that's kind of how we can use satellites here to track hurricanes and forecast their intensity. Another way we can gather data on hurricanes comes from recon missions by hurricane hunters. And so these missions collect data on pressure, wind speeds, temperature, and dew points inside hurricanes. This is done by launching dropsondes into the storm of interest. Dropsondes are pretty similar compared to radiosondes that gather the data to create the SKUTs that I show on this channel. The main difference is that in these recon missions, they drop these sondes in from the air down to the surface instead of launching them into the atmosphere. So here's an example from Hurricane Ike back in September of 2008. I don't have any examples from Hurricane Ernesto because they haven't launched any for the past 6 hours, so I don't have any examples to show you there, but I do have one from Hurricane Ike. Here, this was launched by hurricane hunters, and so we can see the temperature and dew point profile in the lowest portions of the atmosphere from inside of that hurricane. The temperature line, the red temperature line here, and you can see the dew point line as well in green. And so where they're closer together, of course, that's where you have more saturated air. And so this can tell us kind of what's going on inside the hurricane. So the last topic that I'll conclude with this video is related to these recon missions, and those are known as vortex data messages. And so these products are a summary of the storm's intensity and characteristics measured by the aircraft. These are very important as the National Hurricane Center relies very heavily on them while making their forecasts. I'll briefly go over some of the information found in these summaries, and I'll put a link in the description below on how to decode these messages if you're interested in learning more. So I'll just kind of go over the high points here. So in the first couple of lines here, we have the time and date and the coordinates that this message is from. And then the next line here, we have the height of the aircraft. And so that's typically at around 700 millibars, or about 3 kilometers off the surface. Line D is information about the eye, which is very important and tells us a lot about what's going on inside the hurricane. So here, what this means is kind of what's beginning the extratropical transition. So this storm is currently transitioning from a fully tropical system to an extratropical cyclone. And then right next to it, this is the minimum pressure measured inside that eye. And then I'll kind of skip down to the bottom here. In the middle here, we have some wind measurements that are taken within each quadrant of the hurricane. But down here at the bottom here, lines P, Q, and R. Those are temperature readings both inside and outside the eye. And then line R is the dew point measured within the eye. So line P is temperature taken outside of the eye. Line Q is temperature taken within the eye. This is important because you want to have, in the warm core systems for tropical cyclones, you want to have temperatures that are warmer inside the eye than temperatures outside of the eye. So that's exactly what we have here. And so typically, warmer temperatures within the eye means you have a stronger storm. And then down here at the bottom, this is any extra information that could potentially help the National Hurricane Center make their forecasts. So this is just some extra information about the maximum flight winds and anything that is ongoing inside the hurricane. So that's all that I have for this video. And so as I close out, you can hit the like button down below and subscribe to the channel if you're new. I will put all the links in the description box below of all the sources that I used for this video. Hopefully it was educational for you and enjoyed watching. That's all I have for today, and I'll see you next time.